Hello everyone, welcome to my channel. So in this video we will be having ncert audible, that is audible ncert. This is the chapter of biomolecules of chemistry, unit 14, biomolecules. Let's start. We'll discuss each and every line of ncert as well as the questions that come in the ncert. We'll also discuss that, so it will be going to be beneficial, and please watch my videos, subscribe to the channel, and consider liking my channel. So let's start. It is the harmonious and synchronous progress of chemical reactions in body which leads to life. What is a biomolecule? It is the harmonious and synchronous progress of chemical reactions in a body which leads to life. A living system grows, sustains, and reproduces itself. The most amazing thing about a living system is that it is composed of non-living atoms and molecules. What is the most amazing thing about a living system is that it is composed of non-living atoms and molecules. The pursuit of knowledge of what goes on chemically within a living system falls in the domain of biochemistry. The pursuit of knowledge what goes on chemically within a living system falls in the domain of biochemistry. So what is biochemistry? The pursuit of knowledge of what goes on chemically within a living system falls in the domain of biochemistry. Chemically within a living system, that is a domain of biochemistry. Living systems are made up of various complex biomolecules like carbohydrates, proteins, nucleic acids, and lipids, etc. Proteins and carbohydrates are essential constituents of our food. Proteins and carbohydrates are essential constituents of our food. These biomolecules interact with each other and constitute the molecular logic of life processes. These biomolecules interact with each other and constitute the molecular logic of life processes. In addition, some simple molecules like vitamins, mineral salts also play an important role in the functions of organisms. Structures and functions of some of these biomolecules as discussed in this unit. In addition, some simple molecules like vitamins and mineral salts also play an important role in the functions of organisms. Structure and function of some of biomolecules are discussed in this unit. Let's start with 14.1, carbohydrates. What are carbohydrates? Carbohydrates are primarily produced in plants. Carbohydrates are primarily produced by plants and form a very large group of naturally occurring organic compounds. Very large group, not small, very large group of naturally occurring organic compounds. These are primarily produced by plants by photosynthesis, of course. Some common examples of carbohydrates are cane sugar, glucose, starch, etc. Whatever is sweet in the carbohydrate is there. Most of them have a general formula CxH2OY, CxH2OY, CxH2O whole Y, and were considered as hydrates of carbon, and are considered as hydrates of. What is the general formula? That is CxH2O whole Y, and were considered as hydrates of carbon, from where the name carbohydrates was derived. Most of them have a general formula CxH2O whole Y, and were considered as hydrates of carbon, from where the name carbohydrate was derived. So what is the general formula? CxH2O whole Y, and it is considered as hydrates of carbon, so that the name carbohydrate was derived. For example, the molecular formula of glucose is C6H12O6 fits into its general formula C6H2O6. But all the compounds which fit into this general formula C6H2O6 is, for example, the molecular formula of glucose is C6H12O6 fits into its general formula C6H2O whole 6, but all the compounds which fit into the formula may not be classified as carbohydrates. For example, acetic acid fits into the general formula. The general formula is CxH2O whole Y. It is also applying to acids, so this formula is not exactly correct. All the compounds which fit into the formula may not be classified as carbohydrates. So Carbohydrates, they are primarily produced by plants and form a very large group of naturally occurring organic compounds. Some common examples of carbohydrates are cane sugar, glucose, starch. Most of them have a general formula CxH2O whole Y and were considered as hydrates of carbon, from where the name carbohydrate was derived. For example, the molecular formula of glucose is C6H12O6, fits into this general formula C6H2O6, but all the compounds which fit into this formula may not be classified as carbohydrates. So this might not be classified as carbohydrates. For example, acetic acid CH3COH fits into this general formula, so that's why this formula may not be classified as carbohydrates. And not only this, C2H2O whole twice, but it's not a carbohydrate. Similarly, rhamnose, which is a carbohydrate, C6H12O5 does not fit in this definition. C6H12O5 does not fit in this definition. Rhamnose. C6H12O5 is rhamnose, is a carbohydrate that does not fit in this definition. A large number of their reactions have shown that they contain specific functional groups. Rhamnose is a carbohydrate, but this does not fit in this definition. A large number of their reactions have shown that they contain specific functional groups. Chemically, the carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones, or the compounds which produce such units on hydrolysis. Some of the carbohydrates which are sweet in taste are also called sugars. The most common sugar used in our homes is named as sucrose, whereas the sugar present in milk is known as lactose. So a large number of their reactions have shown that they contain specific functional groups. Chemically, carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones. Similarly, rhamnose C6H12O5 is a carbohydrate but does not fit in this definition. A large number of their reactions have shown that they contain specific functional groups. Chemically, the carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones, or the compounds which produce such units on hydrolysis. Chemically, the carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones of the compounds which produce such units on hydrolysis. Optically active polyhydroxyaldehydes or ketones. So what is the best definition for carbohydrates? Optically active. The optically active means they are having chiral center, they are not having planar symmetry, they are not having any symmetry. So optically active polyhydroxy, it is having so many OH groups, alcoholic groups, aldehyde, or it can be a ketone, or the compounds which produce such units on hydrolysis, or the compound which produces such units on hydrolysis are called carbohydrates. Some of the carbohydrates which are sweet in taste are also called sugars. So similarly, you can say that the carbohydrates which are sweet, they are called sugars. The most common sugar used in homes is named as sucrose. The most common sugar used in our homes is named as sucrose. The most common sugar used in our homes is named as sucrose, the sugar we use. Whereas the most common sugar used in our homes is named as sucrose, whereas the sugar present in milk is known as lactose. Carbohydrates are also saccharides. Greek saccharum means sugar. So most common used sugar that we use in our homes is called sucrose, whereas the sugar present in milk is known as lactose. Milk sugar is nothing but lactose. We study this in biology also. Lactose is milk sugar. Milk protein is casein. Carbohydrates are also called saccharides. Greek saccharon means sugar. So carbohydrates are also called saccharides because in Greek it is sugar. Saccharide is sugar. Classification of carbohydrates. Carbohydrates are classified on the basis of their behavior on hydrolysis. They have been broadly divided into following three groups. Carbohydrates are classified on the basis of their behavior on hydrolysis. Carbohydrates are classified on the basis of their behavior on hydrolysis. Carbohydrates are classified on the basis of their behavior on hydrolysis. So based on the behavior on hydrolysis, we can classify carbohydrates. They have been divided into the following three groups. So now we are going to study classification of carbohydrates. They have been broadly divided into the following three groups. Based on the behavior on hydrolysis, we have divided into three types: monosaccharides, oligosaccharides, and polysaccharides. A monosaccharide means a carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxy aldehydes or ketones is called as monosaccharide. A carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxy aldehyde or ketone is called a monosaccharide. A carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxy aldehyde or ketone is called a monosaccharide. But 20 monosaccharides are known. How many? 20 are known to occur in nature. Some common examples are glucose, fructose, ribose, etc. So they cannot be hydrolyzed. They cannot be hydrolyzed into a simpler unit of polyhydroxy. Already they are simpler. Then how can they become more simpler? They are already simpler, so they cannot be hydrolyzed further. So these are the most simpler unit of polyhydroxy aldehyde or ketone. So it is called a monosaccharide. So about 20 monosaccharides are known to occur in nature. Some common examples are glucose, fructose, ribose, etc. So ribose is present in RNA. Ribose sugar, it is a monosaccharide. Glucose monosaccharide, fructose monosaccharide. Now oligosaccharide, carbohydrate that yield 2 to 10. It will yield at least 2 or maximum 10 monosaccharide units on hydrolysis are called oligosaccharides. They are further classified as disaccharide, trisaccharide, tetrasaccharide. So in oligosaccharide only, if they give 2 products on hydrolysis, then they are called disaccharides, 3 trisaccharides, 4 tetrasaccharides, etc. Depending upon the number of monosaccharides they provide on hydrolysis, amongst these the most common are disaccharides. The two monosaccharide units obtained on hydrolysis of a disaccharide may be same or different. For example, 1 molecule of sucrose on hydrolysis gives 1 molecule of glucose and 1 molecule of fructose, whereas maltose gives 2 molecules of only glucose. So amongst these, the most common are disaccharides. The 2 monosaccharide units obtained on hydrolysis of a disaccharide may be same or different. See, you have taken a disaccharide, it undergone hydrolysis, then it has given 2 monosaccharide units. These 2 monosaccharide units may be different or may be same. For example, 1 molecule of sucrose on hydrolysis gives 1 molecule of glucose. How many? 1 molecule of glucose and 1 molecule of fructose. So sucrose is a disaccharide because on hydrolysis it is giving 2 monosaccharides. These 2 monosaccharides can be same or can be different, but in case of sucrose they are different. One is glucose and another is fructose, whereas maltose gives 2 molecules of only glucose. Maltose gives 2 molecules of only glucose, so it is also a disaccharide. Now talking about polysaccharide, we have said that monosaccharide cannot be hydrolyzed, do not give any product on hydrolysis. It cannot be hydrolyzed into more simpler unit. Oligosaccharides 2 to 10. Okay, polysaccharide means carbohydrate which yield a large number of monosaccharide units on hydrolysis are called polysaccharide, more than 10. Some common examples are starch, cellulose, glycogen, gums, etc. Starch, cellulose, glycogen, gums, etc. Polysaccharides are not sweet in taste and they are also called non-sugars. Polysaccharides are not sweet in taste, so you can call it as non-sugars because it is not sweet. The carbohydrate may be classified as either reducing or non-reducing sugars. The carbohydrates can be reducing or non-reducing sugars. All those carbohydrates. So how can we say they are reducing or they are not reducing? All those carbohydrates which reduce Fehling solution and tolerance reagent are referred to as reducing sugars. All those carbohydrates which reduce Fehling solution tolerance reagent are referred to as reducing sugar. Fehling and tolerance. All monosaccharides, whether aldose or ketose, are reducing sugars. All monosaccharides, whether aldose or ketose, are reducing sugars. So all the monosaccharides, whether they are aldose or ketose, they are reducing sugars. So let's talk about what is the tolerance test and what is Fehling's test. So tolerance test on warming an aldehyde with freshly prepared ammonical silver nitrate solution. So what is the tolerance reagent? What tolerance test? That is ammonical silver nitrate solution. Ammonical silver nitrate solution. Ammonical silver nitrate solution. Ammonical silver nitrate solution. It's nothing but tolerance reagent. So on warming an aldehyde with freshly prepared ammonical silver nitrate solution, that is tolerance reagent, a bright silver mirror is produced due to the formation of silver metal. The aldehydes are oxidized to corresponding carboxylate anion. The reaction occurs in alkaline medium. The aldehydes are oxidized to corresponding carboxylate anion. The reaction occurs in alkaline medium. Okay, so aldehydes are oxidized to corresponding carboxylate anion. The reaction occurs in alkaline medium. The reaction occurs in alkaline medium. So you have to take aldehyde and freshly prepared silver ammonical silver nitrate solution, that is tolerance reagent. So what is the positive test? That is bright silver mirror is produced due to the formation of silver metal. The aldehydes are oxidized to the carboxylate anion. This reaction occurs in alkaline medium. So these points are from ncert, aldehydes, ketones or carboxylic acids, page number 369. So let me show you. So this tolerance and Fehling's test is given in the ncert itself in aldehydes and alcohols. You can check the page. So a bright silver mirror is produced, that is positive test for tolerance. So aldehydes gives, but ketone sugars also give. Ketose sugar also give, because I will say you later. It will come in the chapter. Fehling's test. Fehling reagent comprises of two solutions, Fehling solution A and Fehling solution B. Fehling solution A is aqueous copper sulfate. Aqueous copper sulfate. So aqueous copper sulfate is Fehling solution A. Fehling solution B is alkaline sodium potassium tartrate Rochelle salt. So alkaline sodium potassium tartrate Rochelle salt. These two solutions are mixed in equal amounts before test. So Fehling reagent, it comprises of two Fehling solutions. That is Fehling solution A, that is nothing but aqueous copper sulfate. And Fehling solution B is nothing but Rochelle salt, that is alkaline sodium potassium tartrate. It is alkaline. Okay, these two solutions are mixed in equal amounts before test. On heating an aldehyde with Fehling's reagent, a reddish brown precipitate is observed. If you heat an aldehyde with Fehling's reagent, a reddish brown precipitate is observed. On heating an aldehyde with Fehling's reagent, what happens? A reddish brown precipitate is observed. Aldehydes are oxidized to corresponding carboxylate anion. These two solutions are mixed before the test. They are mixed in equal amounts. On heating an aldehyde with Fehling reagent, a reddish brown PPT is obtained. So on heating an aldehyde with Fehling's reagent, reddish brown PPT is observed. Reddish brown. Aldehydes are oxidized to corresponding carboxylate anion, same as in tolerance test, but here red copper PPT is formed. Reddish brown PPT is obtained. Okay, reddish brown, dark brown, reddish brown. Aromatic aldehydes do not respond to this test. So this aromatic aldehyde, they do not respond to this test. As CHO plus copper 5 OH minus, because it's a alkaline sodium potassium tartrate. So you will get carboxylate anion, and a red brown PPT is formed because of Cu2O and 3 water molecules. Reddish brown PPT because of Cu2O. So because of Cu2O, reddish brown PPT is formed. So now let's come back to the chapter biomolecules. Let's talk about monosaccharides. Uh, let's talk about monosaccharides. Let's talk about introduction of monosaccharide, then preparation of glucose, and all about glucose we'll discuss in the next video. Monosaccharides are further classified on the basis of number of carbon atoms. So monosaccharides are further classified on the basis of number of carbon atoms. On the basis of number of carbon atoms, you can classify monosaccharides and the functional groups present in them. Based on these two things, basis of number of carbon atoms and the functional group present in them, you can classify monosaccharides. If a monosaccharide contain an aldehyde group, it is known as aldose. If a monosaccharide contains an aldehyde group, it is known as aldose, and if it contains keto group, it is called ketose. O is for sugar, right? Number of carbon atoms constituting the monosaccharide is also introduced in the name, as it is evident for the examples given. Number of carbon atoms constituting the monosaccharide is also introduced in the name. See in the table 14.1, different types of monosaccharides are given. Central term, aldehyde, ketone. Number of carbon atoms. If 3, triose, aldehyde, aldo, triose. General term you can say triose because it's a sugar. If you want to define whether it is aldehyde or ketone, you have to use aldo triose. Tri for 3 carbon atom sugar. That is glyceraldehyde basically. Aldo triose, keto triose. For 4, tetrose, aldo tetrose, keto tetrose. 5, pentose, aldo pentose, keto pentose. 6, hexose, aldo hexose, keto hexose. 7, heptose, aldo heptose, keto heptose. So these are all the, just you have to write aldo prefix for aldehydes and keto prefix for ketone sugar, ketone containing sugar, that is ketose. So let's see, for 5, pentose, right? Then will become aldo pentose, keto pentose, triose, aldo triose, keto triose, tetrose, hexose, heptose, aldo hexose, aldo heptose, keto hexose, keto heptose. That's it. So remaining from glucose onwards, preparation of glucose, structure of glucose, which is very important part from these questions are must. So we will discuss in the next video. So this was just a brief introduction. Each and every point of NCERT is covered. Thank you. Please consider subscribing to my channel. That gives me motivation to mix and improve my videos. Thank you.